Okay, so we're going to have a look at another ordinary differential equation. So we've seen one second order differential equation so far. We're going to have a look at another one. So we are going to have a look at, the question here will be y double prime plus y prime minus 2y is equal to 0. This is the same as d squared y dx squared plus dy dx minus 2y is equal to 0. We do have initial conditions for this one. We are told y of 0 is equal to 1, and we are told y prime of 0 is also equal to 1. So this tells us that when x is equal to 0, y is equal to 1, and y prime is also equal to 1. So we'll have a look at the characteristic polynomial. So we have y double prime plus y prime minus 2y equals 0. So the characteristic polynomial is formed by making a polynomial consisting of the coefficients of these terms. So this coefficient is 1, this coefficient is 1, this coefficient is minus 2, and then we're just solving the quadratic that has these same coefficients. So this is x squared plus x minus 2 equals 0. Well, we can factorize this. This becomes two numbers that add to make 1, multiply to make minus 2. It'll have to be plus 2 and minus 1. This will be x plus 2 times x minus 1 is equal to 0. This is solved when x is minus 2 and or when x is 1. Now, if we solve the characteristic polynomial, this polynomial, and we find two real distinct solutions, two real distinct roots, then we know the solution y of x takes the form a times e to the alpha x plus b times e to the beta x. This is where alpha and beta are these solutions. This is alpha, this is beta, and a and b are unknown coefficients. So this gives us our general solution straight away. Our general solution is going to be y of x is equal to a e to the minus 2x plus b e to the x. So we have our general solution, and now we're going to use our initial conditions in order to find a specific solution. Well, we need to differentiate this before we can evaluate the function and the derivative. As it turns out, this is quite easy. So this is the function. The first derivative, these are just exponentials. So y prime of x ends up being minus 2a times e to the minus 2x plus b e to the x. This is the first derivative. And now we're going to evaluate both of these simultaneously to solve for a and b using this information that we gained down here. So the first one, I might separate these. I'll move this bit down here. We'll do them both on the same page. We'll do them both. Whoop, lost my spot. We'll do them both on the same page. And we'll move this here. So the first one, we end up with y of 0, that's going to be 1, is equal to a times e to the minus 2 times 0, which is to the minus 0, plus b e to the 0. So this implies both of these are equal to 1. And so this gives us 1 is equal to a plus b. So we have a is equal to 1 minus b. So this is our first equation. The second one, we have y prime of 0 is equal to 1. This is equal to minus 2 times a times e to the minus 0 plus b times e to the 0. These e to the 0s again become 1. So this gives us 1 is equal to minus 2a plus b. If we rearrange this for a minus b from both sides, divide both by minus 2, we get a is equal to 1 minus b over minus 2. This is our second equation. We can use this equation and this equation to solve for b. So I'm just going to set them equal to one another. So this gives 1 minus b is equal to 1 minus b over minus 2. Multiply both sides by minus 2. I have minus 2 plus 2b is equal to 1 minus b. I'll add b to both sides, add 2 to both sides, and I'll get 3b is equal to 3, so this means b is equal to 1. If b is 1, a is 1 minus b up here, that means a is 0. So we get b is 1 and we get a is 0. If b is 1 and a is 0, this means our specific solution is going to be y of x is equal to a times e to the minus 2x, so that will be 0 times e to the minus 2x, plus b times e to the x, which will be 1 times e to the x, which is e to the x. This is just y of x is equal to e to the x. So this is our specific solution. Now that we have our specific solution, we want to test this. So if y of x is equal to e to the x, this implies that y prime of x is equal to e to the x, and this implies that y double prime of x is equal to e to the x. So we have the function here, we have the first derivative here, we have the second derivative here. We're going to plug all of these in to the differential equation we started with. So this implies that y double prime, this is our check, of course, we're checking to make sure this works. Y double prime plus y prime minus 2y equals 0. We're going to plug everything in. We get e to the x plus e to the x minus 2 times e to the x is equal to 0. This is true. This reduces to 0 equals 0. This is true. And so therefore the question is done. We found the specific solution, y of x equals e to the x, and we confirmed that it worked. This one was a relatively short second order DE. So this one worked quite nicely because when we found the solution, the coefficients cancelled multiple parts, and it was just the characteristic polynomial had real roots, and so the solution was easier than if you have a characteristic polynomial that has imaginary roots.